This is a demonstration that illustrates what happens to the energy from glucose during cellular respiration. So I've got this bottle of colored water here, labeled glucose. Let's say that this represents the energy that's in glucose. Now, remember, the primary purpose of cellular respiration is to take the energy that's found in glucose here and transfer it into the form of ATP, which is the energy currency of the cell, what the cell will spend when it needs to do active transport or to move, say. But what we see in this process is that we don't just take all of the energy from glucose and put it directly into this jar here. So let me demonstrate what happens. So the first step of cellular respiration is glycolysis. What happens during glycolysis, if you remember, is that we do make a little bit of ATP. So I'm going to go ahead and transfer some of that energy into my ATP here. However, what happens to most of the energy that's harvested at this step is that it goes into our electron carriers, in this case, NAD. So let me put some of the energy in there. Now, when NAD accepts the energy, it's in the form of those high energy electrons, so it becomes reduced and we form NADH. Next, during the Krebs cycle, or the citric acid cycle, we form a little bit more ATP directly, but we also make more reduced electron carrier here. Now, in the third and final step of cellular respiration, electron transport, here's the energy payoff stage. Here is where we take our reduced electron carriers and we transfer that energy into ATP. And in doing so, our electron carriers become oxidized back to their original form that does not have the H attached to it. So once again, that process is during glycolysis, we make a little bit of ATP directly, but we put a lot of that energy into NAD and FAD here and reduce it. During the Krebs cycle, the same thing happens. We make a bit of ATP directly, but we put most of that energy into the form of reduced electron carriers. And then finally, during electron transport, this is when we actually make the majority of our ATP from this process here. Now, what happens when the cell wants to break down glucose, but there isn't any oxygen available? Well, the process starts the same way. We're going to take some of our energy from glucose, and during glycolysis, we will make a little bit of ATP. And then we'll make some reduced electron carrier NADH. Well, if there's no oxygen available, we actually cannot do the next step. We can't do the citric acid cycle or Krebs cycle, and we can't do electron transport. So let's just do a little more glycolysis. We'll make a little bit of ATP, and we'll make some more NADH. Still stuck, we can't do more of the remaining steps of cellular respiration. So let's just do some more glycolysis and make some more NADH. And we'll have to just keep this going, right? A little bit more glycolysis to make a bit more ATP and some more NADH. Now, as you can see here, I'm running into a bit of a problem, right? If I keep going, what's going to happen to my NADH bucket? It's going to get filled up, and I won't be able to keep this process going, right? In fact, in the cell, once all the NAD plus gets used up and turned into NADH, the process of glycolysis and hence making more ATP would stop. So what happens instead is a process called fermentation. For this part, I'm not actually going to take this energy here and transfer it into ATP. It is actually going to get wasted or lost. And so to show that, I've got this trash can here on the side. And I'm just going to take the energy here and I'm going to pour it out into the trash. Now, it's kind of a waste, but the good thing about this is now we've emptied out our NADH back to NAD+, which means that it can continue to pick up more electrons and we can keep glycolysis going. So let's do that. Let's make a little more ATP, and we'll make some NADH. A little more ATP, a little more NADH, a little more ATP, a little more NADH. I think you get the idea. This is obviously a lot less efficient than cellular respiration because we're only making a little bit of ATP at a time. But it's better than nothing. And when this jar gets filled up, I can just empty out the energy and electrons that are here, turn it back into NAD+, and keep this process going. And that's the whole idea behind fermentation.